हाय विज्ञान ज्ञान संज्ञान के हमें सभी प्रबुद्ध दर्शकों को मेरा यानी अशोक श्रीवास्तव का नमस्कार। रविवार की सुबह फिर आ गई और मैं हाजिर हूँ एक नए लेसन के लिए। पिछले सप्ताह मैंने लाइट के ऊपर प्रिज्म और एक स्लैब उसके बारे में बात किया था, जब हमने रिफ्रैक्शन, रिफ्लेक्शन, डिस्पर्सन एंड स्कैटरिंग ये फीचर्स के बारे में बताया था। आज एक सिंपल दूसरा टॉपिक ले रहे हैं, वो है लेंस का। और लेंस में भी एकदम कॉमन चीज़ कॉन्वेक्स लेंस, स्पेसिफिक कॉन्वेक्स लेंस उसके बारे में कुछ बातें आज आपको बताई जाएंगी। इसके पहले कि चालू करूं, एक थोड़ा सा जो प्रिलिमिनरी वर्ड्स यूज होते हैं उसमें वो हम बता देते हैं, तो समझने में थोड़ी आसानी होगी। रिफ्रैक्टिव इंडेक्स पिछले बार बता दिया था। इट इज़ ए रेशियो ऑफ वेलोसिटी ऑफ लाइट इन एयर टू द वेलोसिटी ऑफ लाइट इन ए पर्टिकुलर मीडियम। फॉर द ग्लास दिस रिफ्रैक्टिव इंडेक्स इज 1.3 to 1.4. It varies between various type of glasses. So now other terms that I will say is, this is the convex lens. There is a line at the center. This another line is center. This is called the principal axis, and intersection of this is called the optical center of a lens. Principal line, optical center of a lens. Now, next item or next terminology is convergent and divergent. So when the light comes from here, there is a lens, and if the light becomes narrower or converges, then this lens is called a convergent lens. But if the same light, if it gets dispersed or becomes broader, then it is a divergent lens. So diverging lens and convergent lens, center of optics and principal line. Now we come to specific thing, that is our convex lens. Convex lens again are of basically two types. One is, this is what is the double convex lens. Both side is the curvature. Then there are plano convex lens. Whereas one side is plane, straight, other side has got radius. So I got two types, pure double convex lens or a plano convex lens. Now these lenses are called the most universal lens and have got so many wider applications. How? It depends on where you are putting the object. Based on that, where the image forms, so it varies from distance to distance. So before explaining that, one more important factor is called the number. When you go to eyesight checking, they give you the lens number. What is lens number? That number is 1 divided by focal distance in meter. If the focal distance is 1 meter, then the lens number is 1. And this is also known as a Doppler number. D-O-P-T-O-R, doctor name, Doppler number. So Doppler number is the number of the lens which is inverse of or 1 upon focal distance. If focal distance is half meter, number is 2. Focal distance is 250 centimeter, focal number is 4. So higher and higher is the number, more and more less, smaller is the focal distance, and the thickness of lens starts becoming more. So you will find that higher number lenses are thicker, lower number lenses are thinner because the curvature is less. Now we define the focal length. What is the focal length? When the parallel light comes and passes through the lens, it converges to a point at a certain distance, and this distance is called f1 or the focal distance. F is the focal distance where a light from infinity, when it comes, it becomes a focal or focused at a point, which is called the focal distance. Then there is a radius of curvature, but that is not of more important. We call it 1f, 2f, 3f. So all the applications are based on the focal distance in terms of focal length. At f1 is the focal length 1, f2 focal length 2 means twice the focal length. Now we explain about this converging behavior of the lens and how it is important where we are using it. There is a lens and this is the principal axis. Now one more thing is about positive and negative. Anything this side, transmitted side, is called as positive. Anything above this line is called positive. Anything on this side is negative. Anything on this side is also negative. You also know what is positive and negative. Anything that is on the other side of the lens is positive. Anything above the principal line is positive, other side is negative. And there one more term which is normally known as the real and the virtual image. So all the optics, it is based on real and virtual image. Virtual image is something that cannot be taken on a screen or any paper. You cannot see that on a paper, whereas the real image you can see on a paper, record on a paper and visually see that. So virtual image cannot be taken on screen, real image can be taken or felt on a screen. You can convert it into a screen and see physically what it is. So virtual image, real image, optical center, principal line, converging image and diverging image. Now we come to actual application. What happens if I keep an object at a distance f, that is at the focal distance of the lens, then the image is also formed at f. Okay. If you keep it at f, it is formed at f and it is of the same height. Means there is no magnification. Whatever the size here, whatever the size here, only thing it is an inverted image. How it comes? It goes like this, comes here and forms a image. If you keep it at f, it forms at f, same distance, real image. When you bring it beyond f, then what is happening? You get a smaller image. I am keeping it here. Then what is happening? This image becomes a smaller. If you keep it beyond f, it becomes a smaller, but still a real one. When you keep it in between f and the lens, then the image is larger than the object. So you get a magnification. So you get three conditions. If you keep it beyond f, it becomes smaller. At the f, it is same. Less than f, it is larger. So all the three have got different applications, right? What for you are using, you will use that power or keep that image. For example, if you keep it very close between f and lens, then it becomes larger. So where you are using it? When you are reading something, you need a magnification. So you keep it very close to the distance. Your eye is here and you keep it here, so it gets magnified. If you want to focus it or increase it, so there are three applications: reading, then next is telescope, third is reading, telescope and camera. So you keep that object at different distances, so you get the three effect. Like for camera, you are focusing it, image at larger distance, it becomes smaller and it is recorded on a recording medium. Earlier used to be film, now it is the disc. You are recording on certain disc. Then I come to next item of this convex lens, that is what we are calling it as a energy transmission. So I will just show you a small experiment where these images keep changing. Just bear with me for some time. Let me make it. I'll just close this is the lens, convex lens. This I am using as a light source just to demonstrate how the image changes. Make it dark. I have kept the light here. Now it is getting focused. When I keep it at infinity, it is getting focused at a particular spot. You can see that spot. The way I keep moving towards the lens, towards the light source, what is happening? Lens is towards the light source, image size is increasing. At a focal distance, these two sizes becomes same, means light source size and object or the image are the same. If I start keeping, when it becomes less than f, then the magnification starts. So the closer you keep it, the larger is the size of the image. Thank you. So this is just a illustration of how the images are increased or focused. When you are focusing infinite image to a focal point, there you are converging all the energy from that light to a specific point. And this is the point where the sunlight, when you convert, it starts burning. The temperature becomes so high. At the village level we were doing, just put a glass on that hand and your hand will start burning. So this is how the energy gets converged to a single point and burn it. This is also used in various defense applications. I'll come to that at some other time. So at this stage, we say the position of the lens, object and the screen are important for different applications. Converging image is used for heating or the bringing the energy together. Diverging image, they are used for magnification purposes. And next one is the magnification of the lens. That is numbered as 1x, 2x, 3x. It is simply the ratio of the image to the ratio of the object. If image is higher than the object, the ratio is more. If the image is lesser than the object, then value is less. So this is how magnification is there. But this magnification has nothing to do with the diopter number or the lens number. They are two different things. One is relative position, other is simply the focal distance and inverse of the focal distance in terms of meter. तो मुझे आशा है कि ये इन्फॉर्मेशन आपको अच्छी लगी होगी. अगर आपको अच्छी लगी आप थम्स अप दीजिए, सब्सक्राइब कीजिए और हमारा हौसला बढ़ाइए. सभी को बहुत बहुत धन्यवाद. आगे के प्रोग्राम में हम इससे कुछ और दूसरे लेंस वगैरह के बारे में बात करेंगे और कोई इंडस्ट्रियल एप्लीकेशन के बारे में बात करेंगे. थैंक यू.